Hi everyone. Today we have just a quick introductory lesson on the concept of factoring, and we're going to start out with the greatest common factor, which is something that you probably learned back in elementary school, but we want to review it in terms of algebra. But before we get to that, let's talk about just what I mean when I say a factor. A factor is a number or expression that divides evenly into another number or expression. So for example, if I think about the number 12, 12 has factors like 3 and 4, because 3 times 4 makes 12, so both 3 and 4 divide into 12. It also has factors like 2 and 6. So all of those things are considered to be factors. So what we're going to start talking about is what it means to factor something, like a verb. Like I'm saying, we're going to do this to something else. So when I say to factor, I mean to break something down into two factors. In other words, another way to say that would be you're going to take something and write it as a multiplication problem. And this word right here, multiplication, that's a very important concept in this process. Everything we do with factoring has to do with multiplication. So for example, if I take the number 15 and I ask you to factor it, I mean break it down into a multiplication problem. So I could write 15 as 3 times 5, and I now have it factored. Now, it's going to become obvious to you eventually why factoring is such a big deal. It is a huge deal in algebra. First of all, we're not going to be doing easy things like 15. We're going to be doing algebraic expressions, and you see some of those down here lower on the page. Secondly, we're going to use factoring to draw some other conclusions about algebraic expressions. The hard part is going to be you're probably not going to see that piece of it this year. So we're going to be asking you to do a lot of this type of stuff, and like I said, it's going to be slightly more difficult ones. And you're not going to really see why it's important yet. So you'll just have to trust us for a little while. When you get to Algebra 2, this will become a really, really major concept. Okay? But like I said, today we're really not even doing any true factoring. We're just talking about a concept called the greatest common factor. So the greatest common factor deals with factors. So like back here we said 3 and 5 are both factors of 15, correct? But we're going to be looking at factors of two different numbers. So let's say I look at, I don't know. We'll just go with 35. If I do the factors of 35, that could be written as 5 times 7. And then I'm looking for the greatest or the largest one that these two numbers have in common. Now in this one, they happen to only have one in common. It's 5. So I would say the GCF of these two numbers is 5. Sometimes they have other ones in common, and we have to be careful that we think about all the different possible factors. So it's the largest factor that two numbers have in common. And in our next lesson, you'll see why that's important in the factoring process. But for today, we're just practicing finding that value. So 12 and 15, can you think of the largest thing that divides evenly into both of these things? And I would say 90% of these I'm hoping you can do without really writing much down. I'm hoping you can look at 12 and 15 and that you're good enough at your times tables that you know something that divides into both of those. So with this one, I would say the GCF equals 3, because the largest thing that divides into both of them would be 3. But maybe you get something crazy like this, 60, 84, and 120. Maybe you don't know this one off the top of your head. Or maybe you know something that goes into all three. Like I could look at these and say, well, 2 goes into all of them. That's a common factor, but we don't know for sure that it's the greatest common factor. We don't know it's the largest. So here's what we can do. I'm going to kind of give you a trick for this. And again, you shouldn't have to do this for every single problem, but it's a good strategy if you don't know the answer right off the top of your head. I'm going to make a list of all the possible factors of 60. And there's an easy way to make that list. I'm going to start with 1. I know 1 times 60 makes 60. Then I'm going to go down the list to 2. well, 2 times 30 makes 60. Then I go to 3. 3 times 20 makes 60. By the way, if you were stuck on any of these, you could be using your calculator and dividing, right? You could do 60 divided by 3, 60 divided by 2. Maybe 4 is a tricky one for you. 60 divided by 4 is 15. 60 divided by 5 is 12. 60 divided by 6 is 10. Now, when I go to try 7, 7 does not divide evenly into 60, so it's not a factor and it doesn't make it on this list. Neither is 8, neither is 9. So 7, 8, 9, none of those work. The next one on my list would be 10, and 10 is already here. So the fact that I came back around to something that's over on this other side means this is a complete list. These are all the possible factors of 60. Now, there's actually a way to get to your answer from here. You could kind of start at the highest number here and work your way down and try to decide which one also goes into these other two. But I'm going to go ahead and just make lists for these other two as well so you can see where I'm pulling these numbers from. So for 84, let's see, and I'm not as good with this one. I don't know as many of these off the top of my head. So 1 and 84. Next I'm going to go with 2, 2 and 42. Okay, 3. I am pretty sure 3 goes into 84. But I don't know what it is off the top of my head. So I'm going to go ahead and do 84 divided by 3, and I get 28. Did you know that off the top of your head? I sure did not. How about 4? 4 should be 21. 5 I know doesn't work because this doesn't end in a 5 or 0. 6 should be, yeah, 6 and 14. 7 and 12. I don't think 8 works. I don't think 9 works. I know 10 doesn't work, right? Because that doesn't end in a 0. And 11 won't work. So 12 would be my next one, and it's already on my list. So there's all my factors of 84. And then last one is 120. This one's going to be pretty large too. 1 times 120. 2 times 60. 3 times 40. 4 times 30. 5 times, let's see, I think it's 24, but let me just double check. Yep, 5 times 24. 6 times 20. Fairly certain 7 does not work, but 8 might. Yep, 8 and 15. I'm not sure about 9. I don't think so. Nope. So the reason I knew 9 didn't work is I checked it over here and I did 120 divided by 9 and I got 13.3 repeating. That decimal means it didn't divide in there evenly. So it's not a factor. Factors always have to divide in evenly. You never want to see decimals in these lists. I know 10 and 12 will work. And then I would go to 11. 11 does not go into 120. And the next one on my list is 12. So now what am I looking for in all of those lists? Greatest common factor is the largest factor that they have in common. Okay, so if I am looking at these, I'm probably going to start from this big end. And realistically, the smaller number is the easiest one to start with because you have a smaller number of numbers to check. So 60 does not show up over here, so I know for sure it's not 60. 30 does not show up over here. 20 does not show up over here. 15, nope. Oh, but 12 shows up over here, right? Okay, so far I'm good with 12. So 12 is here. 12 is here. Does 12 also show up on this list? Yes, it does. So the largest number that shows up on all three lists is 12, okay? And so that means back here I could say that the GCF is equal to 12. Now I wanted to take a minute and just demonstrate this process where you kind of lay all the factors out. Because if we were in class and you asked me, for help on how do I find GCF of these two, this is the first thing I'm going to make you do. But you could have also gotten away with just making that list for 60 and then kind of checking these numbers against the 84. So you could have done 84 divided by 60, 84 divided by 30, 84 divided by 20. And a lot of those you're going to know in your head won't work. So you could have just worked off of this list until you found one that worked and then just made sure that it worked with 120 as well. Okay, so let's get into some actual algebra here. So this time we've got some x's in there. And the 3 and the 18 we're going to do just like we've done these other two. Just what's the biggest thing that divides into both of them? Well, the only thing that can divide into 3 is 3. So as long as that works in 18, that's our answer, right? So for this one, I'm going to say that the GCF definitely starts with 3. Then we have to figure out those x's. So 3x squared would look like this. And 18x to the 4th would look like this. So the question is, how many do they have in common? Now, we already took care of the 3 and the 18, right? So they have 2 of these in common. And so that's really equal to an x squared that they share in common. And so that goes into my GCF. My GCF would be 3x squared. So it's weird to think about. When you're looking for the greatest common factor, the greatest thing that they can have in common is however many the smaller number of x's has, right? Because it's not possible for them to have 4 x's in common if this one only has 2. So whenever you're looking at the variables, you're always looking for which one has the smallest, and then that's how many they're all going to share. Okay, so let's try this next one. It should go faster. 20, 30, and 50. I hope you can do that one without having to make a list. Biggest thing that goes into all 3 of them is 10. By the way, we are going to talk about in the next lesson when we actually start using this to do some true factoring. What happens if you don't pick the biggest number? Like maybe you had chosen 5 instead of 10 here. And there is a way to kind of catch yourself in the process. You still have to fix it, but there is a way to catch it. Then I'm going to look at the A's. So I have A to the 4th, A to the 7th, and A to the 5th. If I line those up like I did over here, 4, 7, and 5, the most I could get out of all 3 of them is this 4, right? They have 4 A's in common. These ones just have a little more than 4. So A to the 4th is going to be part of my GCF. Take a quick second and see if you can figure out how many B's these things should have in common. I have a B to the 6th, B to the 3rd, and B to the 5th. Well, if you said B to the 3rd, you are correct. Okay? They have 3 is the smallest number of B's, so that's the most that they can have in common. Okay, so looking at this last one here. 16, 25, and 81. Is anything popping into your head that they would all have in common as factors? I can't think of anything. Real quick here, just to check. 16 is 1 times 16, 2 times 8, and 4 times 4. And then since 4 is already on the list, I know I'm done. That's all the ways I can make 14. 25 is pretty short. 1 and 25 or 5 and 5. Those are your only choices. And 81 could be 1 and 81. 2 doesn't work, so 3 and 27. 4, 5, 6. Yep, 6 won't work. 4, 5, 6, 7, and 8. None of those will work. And if you're not sure about that, you can check them on your calculator. Okay? By the way, divisibility rules will save you here. And I don't know if you've ever actually been taught divisibility rules, but if you haven't, look them up. Okay? There's some really cool tricks you can do with numbers to try to figure out what divides into what. So 4, 5, 6, 7, 8 all don't work, and then my next one would be 9. So if you look at the 3 lists and you look at what they have in common, you should notice there's only one thing they have in common, and that's the 1, right? So when all they have is a 1 in common, that's what's called being relatively prime. Now, we don't actually know if that's true here yet because we have to look at our x, y's, and z's, right? But they don't really have a common factor other than 1, and 1 doesn't really count, okay? So now let's look at the x's. Well, these 2 have x's in common, but this one doesn't, right? So they don't have any x's that all 3 of them share. These 2 have y's in common, but this one doesn't. And these 2 have z's in common, but this one doesn't. So there are no letters that all 3 of them have in common. And in order for it to be a GCF, it has to work in all 3 of them. So there's no letters, and the only common factor we have here is 1. If you were really pressured to give a GCF, you could say that the GCF is 1 here with no letters attached. But we can also call this relatively prime. Okay, so your first assignment this week is to give a few of these a try. Okay, we've got some worksheets for you that you're going to work on and just work on identifying the GCF. And then in the next lesson, we're going to show you what to actually do with that information.